Okay, and we're live. Before we get started, we're going to do a quick audio alignment test. So, Joao, I'm going to start my Audacity right now. In 3, 2, 1, click. And synchronization clap. Can never get used to that. And then your end.
And my sync clap. There you go.
There we go. Alrighty then. So let's get started then. Hello and welcome to Enterprise Linux Security, getting pretty close to episode 100 here at episode 95. How you doing, Joao?
All good. As always, a pleasure. Yeah, we might get to 100 during the summer. Let's see how vacations get in the way or not. But yeah, we have a few more stories to cover today. So let's get right onto it.
Yes, let's do that. So first thing, I just want to mention a couple business-related things on my end, of course. Just wanted to let anyone who didn't already know, I have a brand new Ansible course out on Udemy. And also there's an LPI course for Linux Essentials that I surprisingly did roughly a month apart, which is kind of incredible. I don't even know how I pulled that off, but they're getting reviewed highly. So definitely check them out. And the links are in the description below already in the video. So if you're watching here on YouTube or later on the website, you'll find the link to those courses. And another thing I want to mention, we have some new products. I know I say that every time, but we are always making new products. So check out the merchandise shop at merch.learnlinux.tv. And I appreciate everyone's support. Thank you so much. All right. So I believe you have an update on a previous story, Joao.
Yeah, we always mention that we'll get back to some stories and then sometimes we don't, but today is an exception. Last episode we talked about regression, which is a remotely exploitable OpenSSH vulnerability that was making the news. And just like always when people start looking at the code, people are going to start finding some issues. And it turns out that the people that are looking at the code around the regression vulnerability managed to find more vulnerabilities. So we now have a few others that operate the same way. And what this actually means for you as a sysadmin and for you doing the work of patching your systems is that now you don't have just one update, but you're going to get more updates to OpenSSH that you should deploy as soon as possible. Because again, remotely exploitable, it gives root, and it's really bad.
Yeah, and considering some vulnerabilities, as we'll talk about later, have been, unpatched at some companies since 2001, truer words have never been spoken. But I digress.
Yeah, and this is likely going to turn into something like Spectre, which is now not just one vulnerability, but a whole family of them, where you have V1, V2, V3, V4, and all of those, and then you're going to have vulnerabilities that work just like that one, but are affecting other packages or are affecting other parts of OpenSSH. So rather than affecting just the login process, might be during the key exchange or might be during the encryption protocol selection. There are many different places where people might start poking and trying to see if the same situation happens. As a reminder, the original issue with regression was that if you started the connection and you never went ahead with the actual login process, the connection would just stay there until it reached the timeout period, which by default was 120 seconds. And at the end of that period, OpenSSH would trigger a system signal, which would get picked up by a few different functions, which were not designed to be run asynchronously. And they were being called asynchronously, meaning that they would run at the same time, and in some scenarios, depending on other load on the system, other processes, how it got delayed or not, there was a specific part of the code that when it happened to run at exactly the right moment and exactly the right situation, it could give you an undefined behavior in OpenSSH that could lead to a remote shell. It's interesting that this attack is not deterministic in that an attacker can just do a specific set of things and trigger it. It's probabilistic, meaning that it has to try it over and over again until that particular set of things happen and it gets the result. So, yeah.
It's like you're trying to create a race condition in the software, essentially.
Exactly that.
Yeah, that's and SSH is something we definitely want to patch. I feel like I say that every episode, but again, I digress. Updates.
again, lowest hanging fruit, as we're going to see in today's episode. Even though it's the lowest hanging fruit, patching your systems and patching your applications, it seems like we're still taking an awfully long time to do that.
So have we ever went over credential stuffing attacks in particular? I mean, I know we've covered password databases and leaks, but I don't think we've ever framed it that way, but the articles do. And I'm talking about what's claimed to be the biggest ever password leak at just shy of 10 billion passwords. Just shy of 10 billion passwords. That's a few. And you know, that if you think about it, a credential stuffing attack is you know, obviously some people, hopefully not anyone listening to the show, will reuse the same password on this site, on that site, because it's easier. So threat actors get a database of passwords that works for Yahoo, then, you know, turns out it works for Microsoft.com. And now, as of July 4th, the new Rock You is out. I'm not talking about an album. That's what the database is called. It's Rock You 2024. I'm not trying to laugh here because credentials have been leaked, and that's never a good thing. We're letting people know about it. We're not saying anything's good, but the name, I mean, it's called Rock You 2024, and see if I can get the number. It was 9.9 billion and some change. I remember that.
Well, at some point it doesn't even... It's not even passwords that have been breached or accounts that have been compromised. It's just a 9.9 billion list of words at this point. Right. So, I mean, it becomes so large that it stops making sense in that you're no longer interested in getting that many different words. You might as well just generate them locally or just use some rainbow tables or something like that to get all of those words in memory. It's just so large that even threat actors might balk at using something like this. The main goal of using password dumps, the main goal of using password dumps like this is that you're testing words that have been used as passwords, and you know that they have been used as passwords at some point because there isn't a single service that has 9.9 billion accounts and got hacked. This is the result of just lumping together multiple breaches, lumping together data that was taken from password dumps from years ago and lumping it all together and creating one giant file. At some point you might just start generating the words locally and you'll likely get the same amount of results and the same amount of hits if you're trying to do a password spray against somebody. Yeah, it's large, it's going to make headlines, but how useful or not it is for something that large to be leaked, I don't know.
Well, there's a bit of debate about it when I'm reading the articles, and I understand both sides. You know, on one side, you have, you know, a would-be threat actor gets a hold of a password database. It makes it trivially easy to do a brute force attack. It's true, you could generate the same information, and that's kind of what the other side is debating. You could use a random word generator and point it to a text file as standard output and get a huge list of combinations of words, phrases, and things like that. But then one argument is it takes time to develop that. And also, these are passwords that have been used. But you can argue that at the end of the day, you're hoping that there's a randomly generated password in there that was reused, that somebody was smart enough to use randomly generated passwords, but not smart enough to, you know, avoid reusing them. I know that would be a small number of people. So I can understand both sides. And yeah, it does make headlines. That's close to 10 billion passwords.
You can be sure that there are not 9.9 billion unique words in there. There's obviously going to be repeats in the middle of there.
So they claim that they're unique in the article. I don't know how true that is, but they do claim they're unique. But 9.9 billion is quite a lot to be unique.
It's quite a lot to be unique, and they would have to be very large for them to be unique. Again, the actual worst of something like this, it's arguable that if you had the password dump half this long, you would get exactly the same results if you used it. What you were mentioning before about us having talked about password spray attacks and the like, I don't know if we've actually delved into password spraying attacks and how that's different from just brute forcing, but it might be relevant to mention it right here. Mm-hmm. When we talked about the Verizon data breach incident report that they put out a couple of months ago, they had information about what had happened last year. The 3 most common attack vectors on incidents, on security incidents, were phishing in the first place, then password spraying and password brute forcing, and then vulnerability exploits. So password brute forcing is when you don't start with a list of known passwords like this, and you just start generating combinations of letters and symbols and trying those against a specific target. That's brute forcing, because you're going through all the combinations. Password spraying is when you take a dump like this and you use these words and try them against all the known accounts on the target system. So you're just throwing passwords that you know have been used somewhere at some point, and then you hope that somebody repeated them. If you take a look at some of the most common words, and there are much smaller lists like this that have like the first 10,000 most common passwords and all of that, it's going to be 1, 2, 3, 4, 5, which is the most common password used. Then it's going to be password, then it's going to be something like I love you, then it's going to be a swear word or two, the usual suspects. And those are going to be inside of this. So you're going to try and password spray that. The accounts that are going to fall for that would fall for that either way. You could use brute force, or you could just try passwords. Again, I fail to see the value in something like this.
There's something that I thought is interesting. It mentioned the article, and I'm quoting directly from the article from Security Boulevard, linked down below. By automating the process, an attacker can try potentially millions of passwords with ease. Now, when I read that, it's one thing to go through 1 million passwords with ease, but when a threat actor has to write a program that churns through nearly 10 billion passwords, I mean, does that would they just have a faster time to break in by not doing that? Because I would wonder if chewing through 10 billion passwords would actually slow them down, and it'd be much faster at that point just to find a vulnerability. Because that's a lot to churn through.
It depends on the target. If you're going to try that over the network, then it's going to take a long time to go through all of them. If you have a password dump that you have locally and you're just trying to decrypt the passwords locally, say you have an Active Directory dump, or you have a shadow password file from somewhere and you want to see what's in there and you're going to try this, again, I'm glossing over the salt factor here, but it might be feasible to do that locally. Again, knowing that there are better and faster techniques if you want to do that locally, for example, rainbow tables that will take a lot of memory but will be orders of magnitude faster than this.
Makes a lot of sense to me, but I think we need to talk about the MFA aspect of this, because, we all hate passwords. I mean, if somebody loves passwords, please write me and let me know. I just want to hear from you, because I think passwords, printers, and DNS are the 3 things that universally are always hated by system administrators. But I digress myself constantly. I'm sorry, where was I? Now I get onto printers and DNS. Anyway, they all agree on this. And it's very rare that, and this is my point, that system administrators, or anybody for that matter, pretty much universally agree on anything. And passwords are hated, but we have solutions. We have MFA, multi-factor authentication, that you could add to it. Passkeys are, proliferating in some form or fashion right now. We have the tools, but what we see is that people just don't use them. They could turn on MFA, but they don't. But it's right there. And then when they get hacked, it's like, oh, you had a chance to turn that on, but you didn't. Why not? And, here we are. Yeah.
The obvious reason is the pushback that you get whenever you try to float the idea that, okay, now all of your users are being forced to use MFA. You're going to get a lot of pushback because your CEO doesn't want to use MFA, and that's likely the most important account that you need to secure. Then your VIPs don't want to use MFA because why should they have to look up another code? They just want to get in and do whatever they need to do.
Right.
And then your regular user will just complain that it's too complicated. So you're going to get a lot of pushback. So either somebody at the top understands the value in enforcing a more secure approach to identity management, or it's going to be really hard to push this from the bottom up. And And the thing about multi-factor authentication, it's not just any type of multi-factor authentication anymore. We know that there is phishing vulnerable multi-factor authentication, like sending SMS tokens. Your phone number might be spoofed, your SIM card might be copied. It's not that hard to receive the SMS and intercept them while the user is trying to get them on the page. There are different methods and different levels of security on the different multi-factors that you can add to this. Biometrics and having something like a USB key, those are likely more secure than just SMS or the messaging and all of that. Even time tokens are not really that resistant anymore. So again, multi-factor authentication would invalidate all of these types of attacks. Password sprays, password dumps, it would no longer matter, but it needs to be correctly applied and correctly implemented. Also, you need at the very least tell your users that they cannot log into your services on public wireless hotspots, because that's the number one place where credentials get stolen and where they get their traffic rerouted to phishing websites.
Right. Yep. That's a very good point. It's so we have to be the example of the change that we want to see, but I do kind of feel like it has to come from the top down. Like you said, that your email provider needs to require it, your bank needs to require it, your library needs to require it, and until they require it, then it's just going to be too often people just don't check the box to turn that on. And then and Steve Gibson on Security Now said the convenience is the enemy of security, as I've quoted a few times on this podcast, and it's never been more true.
Absolutely. And yeah, we're gonna see even more good practices like this in the follow-up stories.
I hope so.
Okay, so moving on. Apparently a China-backed group is doing what these types of groups do, and it's breaking into networks. That would be just another Monday at the office, but what's interesting here is that they are targeting a specific subset of vulnerabilities. Their main attack vector is going for unpatched software, and they are targeting Microsoft Exchange, Atlassian's Confluence, and I'll let you rant about Atlassian in a moment, and Log4j. What all of these have in common, you might ask, is that the vulnerabilities that they are trying to exploit are all from 2021. And they are still being successful in deploying the attacks, and they are still being successful in using these vulnerabilities to get into networks. So think about that. You have vulnerabilities on services that you're administering for over 3 years now, and they are still unpatched. How you consider your services to be secure at this point, it's beyond anybody's guess.
And, here's my Atlassian rant. We were, the companies I've worked with that were using Confluence, it's like we were chasing a CVE to patch constantly. This big CVE, that big CVE. It was just a never-ending thing. But, personal opinion aside, let's look at the fact. The fact is it's used by a lot of companies. And another fact is a lot of big name companies use Atlassian software. So someone that is able to bypass or utilize the vulnerability in Confluence, there's really big name companies out there. And Microsoft Exchange, I don't even think I need to mention anything about that. I think we all know that's everyone's moving to the cloud, but there's still people running Exchange server. There's also Exchange in the cloud, although I haven't followed if that's still a thing. But either way, it's used by quite a few companies. And with Log4j on there, from our show some time back, it's there just as we probably predicted it would be when we did the episode.
Yeah, and at some point we make fun of the naming of vulnerabilities and how that's useless and how that takes attention from other vulnerabilities that might be just as severe or even more. And it looks like not even that amount of publicity around named vulnerabilities is enough to get people to realize how important it is to patch them. Log4j is one of the most widely discussed vulnerabilities of the past, decade, if you're going to go that far. It made news outside of IT space. It made CNN. It made regular news that never even tried to reach IT people. And even with all of that exposure, there are still companies running Log4j versions that are susceptible to the vulnerability after 3 years that are not patching. And again, this is not just internal stuff that you have segmented off the internet. This is stuff that you can scan with publicly available tools like Shodan, for example. It will come up on the reports of Shodan. It's very easy to scan your domain to see if you're vulnerable to this, because you just need to insert the right query into Shodan, and you're still not patching it. I mean, at some point it stops being an issue with patching and getting the right approvals to get the maintenance windows through. You're just not paying enough attention to the problem.
Unless, and I know this would not be an idea that would go well, but unless cloud providers, enforce that vulnerabilities be patched in order for access to be allowed. I mean, it's just that we see companies that seem like they live in fear of their systems. They're in fear of their servers. They're afraid to change this. They're afraid to change that. The slightest tweak gives them anxiety. And, I totally get that, but opposition towards updates is just not the answer, because you're just, delaying one problem while creating another one at the same time. Now you have two problems. That's what ends up happening.
And it's interesting that most organizations, most companies that have on-premises or in the cloud systems and all of that have any amount of servers running, they will also be subject to some type of compliance requirements. There's hardly any compliance requirement touching on IT these days that does not mention patching vulnerabilities on a timely manner. They might not specify exactly what timely manner means, but it sure as hell does not mean 3 years. Right. How these companies not patching the systems are still meeting compliance requirements is again a mystery.
It's a good point. I mean, yeah, how are they getting away with that? The numbers don't line up. The numbers that of companies that are trying to be in compliance or need to be in compliance or state they are, and then the number of people that don't update. Those are conflicting numbers for sure.
The Venn diagram for that shouldn't overlap, and we're seeing lots of overlap there. There's people not patching for prolonged periods of time, and they are still being compliant, or at least claiming to be compliant. And this affects a whole host of different things. If you're doing business with the US government, for example, they will require that you follow a certain set of compliance requirements. And your contractors as well, and the companies providing you with services as well, all the way down the chain. And you're telling me that some companies are not patching for 3 years? I mean, at some point the whole system is broken and somebody has to pay more attention to this, because it's really not fit. This wasn't enough 15 years ago. If you took 3 years to patch a vulnerability, 15 years ago you were going to get hacked. It doesn't matter if you're a large company or you're a small company. If you had systems running outdated software for 3 years, it was just sheer luck that wouldn't see you compromised after that time. Today, at the pace that things go, with the amount of attacks and the amount of probing on the internet that is happening constantly, taking something like Log4j that is widely known to be vulnerable, that everybody knows it's vulnerable, not just the white hackers, not just the sysadmins. The threat actors know exactly that it's vulnerable, know perfectly well that it's vulnerable, and they're actively looking for that. It's really not feasible to understand the mindset of a company that says, okay, we have a vulnerable system and we're very happy with that vulnerable system. We're going to take the risk and we're not going to patch it. If you have CentOS 7 systems that went end of life at the start of this month, and you're not going to patch them for 3 weeks, I'm not even going to go 1 month or let alone 3 years. If you don't patch them for 1 month, or again, you're very likely to going to start seeing problems on those systems. It was just a matter of blind luck that regression didn't affect CentOS 7. There are still lots of systems out there running it. They know they're not going to get updates. They know they're no longer supported, and they're still running them and accepting the risk. Again, there's no way to put this nicely. It's just untenable, the situation. It's unsustainable.
There's no excuse. And it's just, amazing to me. I mean, we have policies, or, trying to be in compliance, that's not working. Naming these things, that's not working. And all we're, updating. And one thing to keep in mind when we talk about end of life systems, when we're talking about CVEs, along with end of life systems, those are vulnerabilities that we know about. We know about them, we name them or give them a CVE identifier. So we're aware of these. But there's threat actors that are aware of more than what we are aware of because, there's vulnerabilities that haven't been reported. And they're hoping that these vulnerabilities don't get patched when the OS goes end of life, because then they have that bank that they can use, and they know people aren't going to patch or update in a timely manner. And another thing to keep in mind is threat actors don't waste their time. If they are looking, there's something to be found. Okay, if they're looking for end of life systems, it's because there's a lot of them to be found. If they're looking for unpatched vulnerabilities, it's because a lot of them are out there to be found. Threat actors, they don't waste their time. They're going right to what they know is there, and it's probably always there every single time they go looking for it.
And they adjust their tools to meet the CVEs that they're looking for. These guys, this supposedly China-backed group, again, I don't know how they established that connection, but regardless, this supposed threat actor group, they have tools that are automatically looking for this type of systems, running these compromised, these susceptible versions, and they're actively searching for the vulnerabilities, the unpatched vulnerabilities. And they are actively finding them. So it's not like somebody is sitting on a dark basement looking at a very bright screen and typing commands manually. This is completely automated. As soon as a vulnerability is out and there's a comprehensive enough description, there's exploit code freely available, this is going to get incorporated into everything from Metasploit to just the tools that they designed themselves in-house. And that just shortens the amount of time that you have to react to these vulnerabilities. Log4j, I mean, that's egregious to take too long to patch. There's the acceptable number of systems that are still susceptible to Log4j after all the publicity, after all the messages and all the scare that was put into people's minds and all the fear that was thrown around Log4j, and the actual risk that the vulnerability has. It's remotely exploitable and it gives you root access, it gives you a shell. It's very easy to trigger. It doesn't take days like regression. So it's just finding the right server, deploying the code, and after a few seconds you have root.
Mm-hmm.
The reasonable number of susceptible servers that can still be found on the internet right now should be 0. There should not be a single server still running a vulnerable Log4j version. I don't really care what that server is doing. There's no excuse for a server not to be patched 3 years after the fact. Again, none. And I am very aware that it's very difficult to schedule downtime. It's very difficult to get all the stakeholders to approve the downtime and make sure that everybody in the company is okay with taking down the systems, and systems going down always causes issues and the downtime is costly and all of that. I'm perfectly aware of that. Telling me that in 3 years there has never been a right moment to take a system down to handle a critical vulnerability like this, that's not acceptable.
They probably could have 1 or 2 power outages within that amount of time, and they went down anyway. I mean, who knows?
Yeah.
It would have been a great time to patch it. But you're spot on. There's just no excuse. It's irresponsible. But I also want to mention, too, I understand there's some system administrators out there that work for companies that are toxic towards IT. Maybe upper management, they see IT as a means to an end, and they hate it. It's costly. It's expensive. It's a drain. And I do know that system administrators often have to, fight for an update because the upper management won't let them do it if they need upper approval. So I do understand the struggle, but to your point, 3 years, there's no reason for that. There's just none.
Okay, now that we've dissed enough on Log4j, let's take a stab at Polyfill. So, Polyfill, if you're not familiar with it, I wasn't, is a JavaScript library. So you design your new website, it's really great, it has all the functionalities, and you go and test it on older browser versions and it breaks. Because the older browser versions don't support this or that, or not very good at rendering specific things. One solution that's very easy, because you just need one line of code and you just need to include Polyfill, is that you add that at the top of the page, you include the Polyfill library, you add the URL where it's being loaded from, and it will magically fix your website so that it runs on older browsers. This saves you having to code all the exceptions for the older browser versions. The webmasters out there know what I'm talking about. It will make it work on mobile. It's all kinds of nice. And it's also been compromised. So Polyfill was available from a specific URL. You would include that URL on your page. The page would work. The code would be available on GitHub. And everything was fine. Some time ago, apparently, again, a Chinese firm, we're not trying to aim at China for any reason, it just turns out that both stories mention it, but a Chinese firm bought the domain and acquired the GitHub project. In some weird world that was possible, the original developer behind Polyfill said that he had nothing to do with the sale, so I really don't understand how it was acquired, but it turns out that it was bought. Sometime later, after the acquisition, some people using Polyfill noticed that users of their websites were being redirected to adult websites, to gambling websites, and yeah, it was tracked down and Polyfill was starting to introduce malicious behavior. Which is great when you have a web page that's supposedly good and secure and represents your organization, and now you open it and you will land on an adult website.
So I think I might have mentioned this before, but every now and then, as followers of the channel know, I'll do a tutorial video. So I'll show you how to do this and that, and I'll show you the process. And then someone might ask me, why don't you just do X, like use a container or use, some package or something that's, I get the ease of that, but for one thing, I don't have as much to teach if there's an easy button, but more importantly, you don't really know what's in it. And that's why, and I know a lot of people won't agree, but I think a lot of people will agree later that don't use a container image from a registry. Build your own. And I know that's harder to do, but you know what's in it. You've chosen the components. I'm not saying that makes you, it impossible to have a supply chain attacks. Obviously some software you're including might itself include other software, but there's still something to be said for knowing everything that's in it. And when you have something that is working fine and you have a library that's good and is doing good things, then it turns evil. And then your users are complaining. It's just a situation where we're, like we said before, we're going to see more and more supply chain attacks. This is absolutely not the last time. And it's probably just going to be more common in the very near future.
Another possible alternative is that when you find the working version of something that you want to use, a library, a container image like you mentioned, and you test it thoroughly and you make sure that there's no malicious behavior there, download it and host your own copy on your own systems and use that copy for whatever you're doing. You're not going to have the latest version until you check the latest version and make sure that it's fine, and you take that one to your server and you run it from there. This isn't a foolproof way, but it's another layer of security that you can add if you're using dependencies. And of course you're using dependencies because they're everywhere and everybody is using them. Mm-hmm. The code for Polyfill was widely available. You could have cloned the repo and have your own copy of it, and you could have found a version that was safe, and you could have linked that to your website. And if you're telling me that companies like Warner Brothers and Mercedes and the like couldn't have spun up an instance and running their own copy on their own systems, yeah, of course they could. But they didn't. And it turns out that those and the initially thought to be 100,000 more websites out there were all running Polyfill. So yeah, it went really bad really quickly. And interestingly, the malicious version, it introduced a new set of behavior to the library. First, it would do this only on mobile. Secondly, it would take care to note the type of user that was running. If the user had root privileges, it wouldn't turn on the malicious behavior. Additionally, if it found that the website where this was being loaded had Google Analytics on, it would also not fire. And likely because it didn't want to be caught on the logs for the analytics. So it knew exactly whoever is coding the malicious behavior knew exactly how to evade detection for as long as possible. And that's the level of innovation, if it can be called that, the level of resourcefulness that you can expect from threat actors doing this type of attack, because they're really clever individuals, and until you respect their abilities, you're not going to take fighting them seriously, and you really need to. Everybody depends on some libraries. Nobody reinvents the wheel. Nobody likes to reinvent the wheel. Developers absolutely hate it. If they find a library that can save them time, that does what they need, they will take the library and run it. Mm-hmm. The thing is, vetting external code is getting harder and harder. It's every time more dependencies, every time more complex dependencies. So at some point you have to find some way of vetting them, or just sticking with the same versions. Again, it might be found at a later time that those versions have vulnerabilities like all code does, so you'll be forced to move ahead and again go through the process of vetting them. But to give you an idea, a couple of years ago, the average number of dependencies on a Java project, and this is again an example for any type of language, was 150. So 150 dependencies on a single project. You would have your own code, which might not be that much, and then you would pull in 150 pieces of code from some randos on the internet. And you would run with it. You would deploy it, and you would package your software, and you'd deliver it to your end users. And that's hardly a secure way to do stuff. But again, it's what we have.
It's a really hard problem to solve because, if I'm a programmer and I need to play a sound effect, the last thing I want to do is create my own library to access the sound card. Someone else has already created a library to interface with the sound card, so I'll just use theirs and then send the WAV file through, and then the rest will just happen. Or, reloading a URL or fetching something from a particular API. There's all kinds of things. And we need to vet these things, but how exactly do we do it? Because regardless of, if you have hundreds of thousands of lines of code, it doesn't matter if it's hundreds of thousands of lines of code in one code base or among multiple libraries. At the end of the day, it's still that many number of lines of codes, regardless of, where it's from. And human error is a very real possibility in any of these libraries. Ill intent, as we've just seen, is a very real possibility. And even if there's nothing going on now, just like with this story, there could be something happening later. And would you notice? Because it sounds easy. Just look for something in the code that doesn't look right. But we're talking about someone who could have something in base 64 that you have to decode somewhere, or, they're really good at hiding these things, like you were saying. So you would have to kind of follow the logic. And if they're trying to utilize a race condition to break into something, that's especially hard to check. So I feel like as more thoughts and discussions come around about how to deal with this, it's something we'll be bringing up repeatedly until we have at least some kind of idea behind a good way to wrangle all these.
At some point, this is going to become unmanageable and we stop trusting software altogether. To give you an idea, I mentioned the original creator of Polyfill at the start of this story. After the sale, a couple of days after the sale, he created a website called Polykill, in which he claimed that people should stop using Polyfill because it was no longer trustworthy and they should remove it from all of the websites. It turns out that the original 100k number of websites that were running Polyfill was lowballed. It turns out that it's more close to 400k, including several government websites that are using this. This is massively dangerous. The fact that they are now just redirecting to adult and gambling websites, that's just a walk in the park. It doesn't really matter much other than the annoyance that the users experience. if they start deploying data stealing techniques, if they start to steal your credentials, if they start to take your banking information or all of that, then it's going to be much worse. If they just start copying your sessions on your banking website and replaying them on some other computer run by the threat actors, it gets much more difficult to handle and much more dangerous. We might not have seen the end of this story for sure, because there are still countless websites out there, still including Polyfill. Again, a named vulnerability, again, lots of publicity, and the websites are still not being updated. One website that was running Polyfill, that was making the rounds and was being called out even on Twitter, was Hulu. If you opened Hulu after this was done, Hulu was affected by this vulnerability. So, yeah.
Why does Hulu want to work on old browsers? I wonder. Like, could they even play the video even if it did load the page? Just curious. Because it seems like a very useless thing for a platform like that. But anyway.
Okay, so that was your bunch of depressing cybersecurity stories for the week.
Yeah.
I'm sure we'll have a new series of depressing cybersecurity stories next week, where people are still doing facepalm stuff that we'll be sure to share with all of you. Yep. As always, it was a pleasure. Thank you very much for all of you who joined, and until the next one.
Thank you.